Welcome to BeyondBIM. Many organizations are contemplating the digital twin journey and perhaps wondering what the transition might look like from BIM to digital twins. Yet, very few know what resources and tools are available to begin designing a digital twin that can help close the loop of occupant feedback into building designs. We've all come across Autodesk Forge, but what about Dasher? Dasher has evolved and is creating that stepping stone that is much needed towards digital twins, particularly with Autodesk products. Today's episode, I'm pleased to bring to you a discussion with Kean Walmsley on the exciting emerging technology developments and R&D projects from Autodesk Research Lab. Kean is a software architect working on projects that integrate IoT data with BIM via the Forge platform, as well as working on generative designs in the AEC space. He has worked various roles and in various countries during his career in Autodesk, including building and managing teams of software developers in Europe, the Americas, and the Asia Pacific. Kean engages regularly with Autodesk's developer and computational design communities, providing technical content and insights into the technology evolution. I first came across his presentation in the most recent AI in AEC conference and wanted to hear more directly from him. So, without further ado, let's hear more directly from Kean on some of the exciting R&D developments from Autodesk Research Labs. Okay, so thank you, Kean, for agreeing to participate in my podcast, Beyond BIM. Now, you were recently a keynote speaker at the AI in AEC conference. Can you elaborate more on the synergy between generative design and improved building operations? I believe that was the topic that you presented on. So can you perhaps give us a bit of insight whether we're anywhere closer to closing the loop between building design and operations?
Yes, absolutely. Well, I mean, I can provide an answer. Not yes, we're getting closer. We are getting closer, but I think it's gradual. And by the way, thank you very much for inviting me to be part of this. It's a nice opportunity to get to know you and so to share some of the work that I'm working on. So yeah, I mean, from my side, I'm most interested really in the sort of synergy between historical operations data and generative design. So this idea of taking building performance data and using that in some way to feed the generative process, or the process where we're going to let's say automatically create a number of designs or optimize designs based on algorithms and data. So the sort of first big project that Autodesk Research did in this space was it's the Mars project we talk about, and this is the Autodesk office in Toronto. So Mars stands for medical and related sciences, not the planet, and it's the Mars Discovery District, which is really a big, the largest urban technology accelerator or incubator in North America. So it's really an impressive place. Lots of big companies and small companies have offices there. So there's a lot of energy there. So Autodesk wanted to have an office there. And as such, we wanted to kind of showcase our design technology to lay it out. So this was our first big test of the use of generative design for architectural layout problems. Mm-hmm. So David Benjamin, who had been brought in to Autodesk Research at the time, he heads up the living, headed the project, and their team, they took data from all sorts of places. They took data from HR, from facilities. They took data from the employees themselves. They asked the employees, well, what do you need from a workspace? And so people did their best to respond. Sometimes they don't always tell you what they really need, but they tell you what they think they need. So there's all this kind of subjective data that they took all this data, and when they were generating the various designs, they validated or they tested the designs based on the data that had been provided to see whether these designs sort of fit the requirements of the people who are going to be using it. So that's one aspect of already we've started to take data into the generative design process. But where I'm interested in, what I'm most interested in, because I'm more focused on the digital twin side of it, if you like, or the projects where we're collecting data from buildings and visualizing it in 3D. I'm really interested in the opportunity to take that data into the generative process as well. So it could be performance of the space in terms of comfort and various things, but could also be how the occupants have used the space. We're using cameras to sort of assess, understand how people are using a space. So one thing that we can start to do is to understand how changes to the space will affect people's behaviors in the space and how they'll make use of it. So that's very interesting, and I think that we could get to the point even where theoretically the generative process is running constantly or on a daily basis and reconfiguring a space based on the anticipated needs of the people who are coming in the next day. Say a co-working space, the whole place could reconfigure itself between overnight, ready for the people coming in the next day. So I think there's some really, this is a bit far-fetched.
The physical world reconfiguring itself.
Yeah.
Okay.
Based on what the system believes that will best meet the needs of the projected needs of the people who are coming in. Mm-hmm. The people who have registered to come into the co-working space. Mm-hmm. Some of them may need large conference spaces, for presentations. Some of them may need small meeting rooms. A lot of this could be potentially kind of configured on the fly, based on some automatic process. Again, a little out there, but we're starting to make baby steps. So back to your original question, are we moving towards this? No, I do think we are, but we're still quite early on in this process of connecting this data into a more generative design process.
Yeah. And you guys are obviously doing this in a research setting, but do you then have examples, kind of flagship examples of success? You mentioned the Mars project, but are there any others where you've seen that the occupants' data and data about how they use that space can then be translated into the design tools that are then used to design a building that's similar to those spaces, for example?
Yeah. So with the specific example of Mars, we had a follow-up project. It was always our dream to really do sort of proper post-occupancy feedback, post-occupancy analysis of the space to say, well, were there some assumptions that we made in the original generative design model valid, and is there something we need to do to get them closer to reality? Now, we have done that to some degree. We'd originally hoped to have kind of an app on people's phones where they can start to sort of provide feedback on the facilities. We didn't get there, but one thing we did do was to sort of analyze, as I said, sort of set up some cameras for a limited time in a certain space. Again, when you have cameras, people do get a bit nervous and they have to opt in. But we were, using an interesting technique, which is something that I did talk about briefly during the AI and AC keynote, which extracts these anonymized skeletons from video footage and essentially positions these skeletons in a 3D space, and you can start to reason about the type of activities that people are performing in a space based on the configuration of it. So that does help with some of the issues we have related to anonymity, but all the same, we only did that for a brief period. We didn't do that for an extended, or a permanent sort of setting, I would say. But yeah, I don't know if I've really answered your question in that sense. We have done some follow-up work for the Mars project. We are we have some other projects more on the manufacturing side where we have some digital twins where, looking more at a process. This is also early stage work, but again, where we'll measure the quality of a manufacturing process and feed that data back into the tool to allow people to make better decisions or ultimately sort of influence the generative design process as well. So that's really, there is going to be somebody involved in that process, whether they're curating a set of generative designs or whether they're just taking the data and using it to design. So I think there's going to be a sort of some stepping stones before we get to the point where we're really influencing generative design directly.
Mm-hmm. And you already briefly mentioned digital twins there, but would you say that digital twins are feasible for smaller organizations? Because we hear a lot about digital twins, but we also realize that, of course, the cost of deploying digital twins is very expensive, at least from what we can gather from manufacturing and aviation.
Yeah.
So how can organizations start their journey, and is it feasible for smaller organizations?
So I mean, we started our work on digital twins in the built environment. I mean, people weren't really referring to them as digital twins at the time. I'm not even sure if people were using the term IoT at the time. This was late 2009. We had the people who started the project sort of had the insight that, the cost of storage for data is coming down, the cost of sensors is coming down, so they're becoming more and more ubiquitous. It'll just be easy to put sensors everywhere inside a building and just capture that data and store it and then start to do meaningful things with it. So we, again, we started that way back in 2009. At the time, we were, running cables down on our, hands and knees, installing all the networking stuff that we needed to make it work, having Raspberry Pis plugged into power with sensors. I mean, all this low-level stuff that you really, and then writing software to send the data from the Raspberry Pis into our database. We built our own database. I mean, not completely our own, but we took a number of different open source databases over the years and sort of broke each one, and then eventually settled on one that scaled for our needs. So we went through that whole process, which is a time-consuming and costly process. There's no doubt. It was always our expectation that things would commoditize further, so that eventually we'd be in a position where our analysis or visualization capabilities could be plugged in to some system that was provided by someone else. And we're getting to that point, where Azure Digital Twins is on the market. AWS, the AWS IoT offering is also there, where people can start to build their own digital twins. It is getting easier, but it's not quite yet sort of plug and play. We're doing explorations with both of those platforms to see how our visualization technology can play a role. But I will say that both of those players, and probably others as well, are investing a huge amount in sort of making it easier for companies to start to deploy their own digital twins. I don't think anybody can realistically do it today without some software expertise and sort of software development expertise, or unless there's something that I don't know about. But it is getting more commoditized and more straightforward.
Right. And I guess what Autodesk has done, of course, is followed in a similar suit to try and make it easier. So, for instance, with Autodesk Forge, how could organizations perhaps start on their journey with digital twins with Autodesk Forge, and what could they expect as a result of using it?
Right. So this is an interesting one, because I mean, when I joined the research team in 2016, I want to say, at the beginning of 2016. So I was asked to look into whether we could take Dasher, which was this, so Project Dasher is our digital twin technology, again, the one we started back in 2009. At the time, it was a desktop application. So it was, it had its own graphics engine, had to read and write from BIM data files. There's a lot of complexity that had to be managed. So the suggestion was that I would explore an early version of Forge. It was called the View and Data API at the time. We hadn't branded it as Forge. But I'd already done previous projects with the API. And so I said, yeah, that sounds really interesting. So I essentially built this Forge-based version along with a couple of other colleagues, and building on a lot of the work that had been done previously in the desktop version of Dasher, because we could reuse some of the code as well. We built out this Forge-based version of Dasher, which really allows you to explore building performance data in a 3D context. So it allows you to animate heat maps for a floor of a building over time, add in data around occupancy where you can see people moving around, so you can get a sense for how that's affecting these heat maps, whether it's for CO2 or temperature or humidity, etc. So all of that is really a powerful way to sort of get people to consume a lot of data. I'm sorry, this is a little bit long-winded, but I will get to the point. But in the end,
that's Dasher, right? You're describing Dasher.
It's Dasher, exactly. So, but because we started to show Dasher and to talk about Dasher, and people started to ask us for Dasher, so the Forge team took an interest, and they said, "Well, actually, there is something here. Let's see what we can build into Forge." So, over the last year and a half or so, maybe even a bit more, the Forge Viewer team has been taking pieces of Dasher and building them into the Forge Viewer. So as of a week or two ago, there's a technology, it's codenamed Project Hyperion, but essentially there is externally we're calling it the Data Visualization Extension. So this is a re-engineered set of components based on the work we did in Dasher that will allow Forge developers to build their digital twin. And there is a full, reference application based on React, which, people who have strong web development skills will be able to take a look at it, and, they'll be able to get running really quickly. So that is kind of the story with Forge, that there is this visualization extension that I'm happy to say was heavily inspired by the work we did on Dasher, that is in the hands of Forge developers right now. And we have every month or so, the Forge team holds an accelerator where people can sign up and come along and spend a week getting up to speed with Forge and just sort of starting to build their first application, whether it's a digital twin or something else. So I think it's usually about the third week of every month. So we just had one last week, the 22nd to the 26th, I think. And there'll be another one that same week in April, I guess.
And so if I understood correctly, then Forge is going to be embedding the work that you've done with Dasher into it. Is that correct?
Yes, they've taken pieces of what we've done inside Dasher. So they've taken the timeline, they've taken the ability to show sensor locations as sprites, so you can hover over them and bring up a tooltip. Yeah. They've taken the heat map capability as well. But Dasher, for all its strengths, is a research project. It's really a prototype. So I'm very happy that they went and they took what made sense to take, but they really engineered it in a way that they can continue to develop and support over time. Mm-hmm. And at some point, I'll probably go ahead and take what they've done and build it into Dasher, so I can rip out a load of old code, which I think would also be a good test of what they've created.
Fantastic. Yeah. That's really exciting to hear, actually. And I'm sure that many people who are considering the journey of digital twins in their organizations can also look into Forge and look forward to those new developments as well. Mm-hmm. So now we did briefly touch on digital twins, but now I want to go a little bit more abstract and talk about how do you see the industry making a transition from BIM into digital twin? Is it a small step or a giant leap?
Well, so again, I'll sort of talk about my own experience with this. When we started Dasher, actually every pilot project we've done with Dasher has started with the creation of an as-built BIM. We've had to send people in, whether it's us or a contractor, to go in and essentially generate a high-quality as-built BIM for the space in order for us to to build a digital twin based in Forge around it. Now, that's just a moment in time as well, right? So, of course, as soon as it's been made, it's out of date because, everything's continuing to change. So this was always, we always knew that this was a problem with this whole BIM to digital twin journey, and it's one that we just from the research perspective, we decided not to address it because our focus was really on just pulling in IoT data and using interesting techniques to visualize and explore that data. So we kind of ignored that and just worked on this assumption that there's just going to be a good quality BIM available. Now, luckily for us, in a sense, a year or two ago, a separate incubation effort inside Autodesk was launched called, well, at the time it was called Construct Twin. It's now called Autodesk Tandem. Now, this is a platform or a product that really is trying to deliver on this promise of having BIM kind of live through from early stage design all the way through construction into operations. That was always the vision for BIM, is that it would, it would just live on and it would be built on, or there'd be versions of it for sure. And you'd have different filters of the data depending on what you needed. But ultimately there'd be, I hate the term, but a single source of truth, right? Now, that didn't really work out because everything ended up being fragmented and things would get handed over, but then they'll be modified, and it just, things kind of got out of sync, and it just, I'm sure you're well aware, is quite messy. But what Tandem is doing is really trying to sort of have a centralized database where you can which can ingest data from Revit or wherever, and sort of maintain this this database that can be queried to get the right level of detail, and is fundamentally the basis for a digital twin where you're starting to bring in IoT data as well. So it's really focused on the modeling aspects of it today, but over time, so really, how are we going to manage this massive data so that it stays in sync with reality, which is a large piece of building a digital twin. It's like maintaining a connection to reality. Mm-hmm. But then later on, I expect they'll hopefully take some of the work that we've done in Dasher or this project Hyperion that I mentioned, the data visualization extension, and then start to build out a feature where you're bringing in IoT data as well. So I think that there is it. So that is also in beta now. So it's something that people can sign up for and give it a try. It's called Autodesk Tandem. I can provide links to that, but you could probably just search for it as well. But that, I think, is making, if it sort of fulfills its promise, it'll turn a giant leap into a much smaller leap. I mean, it's still not, your feet will probably still have to leave the ground a little bit, but it's not going to be, crossing this enormous, chasm to get to the other side. I think that it's making it a lot more feasible to go from BIM to a functional digital twin.
Yeah, the first thing I thought of when you mentioned database was actually originally, if I'm not mistaken, before it was called BIM, it was referred to as building database. So it's really exciting how it's actually going back to its origins, or how it was initially conceptualized by Eastman, that it really is a buildings database that is just continuously updated throughout its lifetime.
Yeah, I think that's. I agree that it's great to see it come sort of full circle in that sense.
Yeah. And now, digital twin is of course very exciting, but the concept itself is going to have a lot of different technologies that are needed to make it a reality and possibility. What are some of the exciting emerging technologies that we can expect to see more experimentation with from Autodesk and its research lab? Yeah,
so Autodesk Research is looking into a lot of different technology areas, I would say. And this ranges from, XR to robotics to, additive manufacturing or traditional, milling, subtractive. It's, there's lots of work going on in terms of sort of hands-on applied technologies, more software related technologies. I think framing it slightly differently, I'd probably say, well, where I think one of the big opportunities is for applying digital twins as part of a process today. When I look at the work that's being done inside research at the moment, aside from this sort of digital twin work that we're focused on, I'm very excited by the work being done around industrialized construction, because I think we really need to fix the construction process and finding ways to make it a lot more industrialized. I mean, again, that's just repeating myself a little bit, is the way, or repeatable, is lowering the cost and the effort, doing a lot more sort of offsite fabrication. I think that there's a lot of technologies that kind of come into play there. And for sure, digital twins will play a role as well. So we are doing an early collaboration with a company in the US called Factory OS. And we will be deploying various technologies there that relate to industrialized construction, whether it's generative design, digital twins. I have a feeling there'll be some robots there somewhere as well. But yeah, so there's a lot of opportunity there to streamline the construction process and make a big difference with it.
Yeah, interesting. I guess in a manufacturing setting as well, it will become a lot easier to deploy some of those emerging technologies.
Yeah, it's a lot more controlled. Absolutely. I'm kind of interested in this space particularly because I'm managing some teams that are focused both on the AEC side of things, but also on the manufacturing side. So we're building digital twin technology across those two industries, and as there's convergence between those industries, there's opportunities, of course, for one to influence the other, and sort of this common technology to be deployed in these environments. But yeah, I do think you're quite right that this controlling the complexity of the problem by putting it into more of a manufacturing environment is a big opportunity.
So you're also a bit of a thought leader when it comes to technology and the latest emerging tech. So where would our listeners be able to find out more about your work and some of its resources? I know you have a very interesting blog available as well.
Yeah, so if you just connect with me on LinkedIn or on Twitter, you can find me at Kean W, Keanw, on both of those systems, or you can visit my blog at keanw.com. That's where most of the content is created, and then I sort of share it through social media. Then you'll certainly find out about the things that I'm thinking about. I mean, I struggle a bit with the term thought leader. I'd love to be more visionary, but I don't find myself very good at predicting the future. You'll probably find out as you come to my blog that I spend just as much time talking about 1980s computing technology than I do things in the future. So, but yes, anyway, I'd be very, very happy to connect with listeners of BeyondBIM, and please do, let me know if you have any questions related to what I've talked about today.
Thank you for tuning in to listen to BeyondBIM podcast. If you enjoyed this episode and want to hear more from our latest episodes, then you can visit BeyondBIM, which is available on SoundCloud and iTunes and all the other major podcast providers.